Wi-Fi release brings all new performance, as well as new acronyms, like this one, 802.11ax, or as we call it now, Wi-Fi 6. It's faster, as you would expect, but not in the same way. You see, rather than bragging rights at the drag strip, think great trunk space, better handling in the rain. You see, Wi-Fi's become a victim of its own success. We are surrounded by access points, all straining to serve more data-hungry devices. In fact, this has become our high-density reality. So density refers to the concentration of something like multiple users with wireless devices. And as we gather, latency gets worse. Things take more time. But look at what happens as density increases on Wi-Fi 6. Latency levels off. Throughput is consistent. Something is obviously different here. We see the 802.11 family dates back to 1997, and every update has made performance improvements mostly from the same three areas: the modulation scheme, the spatial streams, or the channel bonding. Well, modulation is the process of shaping an analog wave to send data, and that wave is defined by a frequency where the amplitude and the phase are altered to indicate unique bits of information. Well, Wi-Fi uses quadrature amplitude modulation, and 16 QAM means 16 possible areas that can indicate specific symbols. Higher QAM means higher modulation, more bits per symbol, like 64 QAM first introduced with 11N, which grew to 256 with 11AC, and now 11AX can modulate as high as 1024. Now that's a lot of data. What's not to love? Well, don't forget wireless is an unbounded, shared medium. Everything affects it. Every signal must be demodulated and interpreted by the receiving radio. So now it may help to look at these squares as targets that get smaller and smaller with each improvement. So higher modulation can increase the data rate, but these tighter constellations only work in the most pristine, low-noise situations. Well, let's consider increasing the number of spatial streams. MIMO is where a single access point can use multiple radio chains to send and receive more data. But very few clients have more than one or maybe two antennas. So the real bonus comes from MU-MIMO, where multiple streams connect with multiple users simultaneously. But this only works if there's enough spatial diversity or physical distance between individual clients, which is, of course, a little more difficult to achieve in high-density situations. So let's consider our third common improvement, channel bonding. The 5 GHz band provides 25 non-overlapping channels. Channels are simply 20 MHz subdivisions. You can double the channel to get to 40 MHz channels, but then you'll only have 12 to choose from. 80 MHz channels exist, that'll drop you to 6, or only 2 if you want to max out at 160 MHz. See, channel bonding reduces the number of available channels, and since enterprise deployments are using multiple APs to get the right coverage, you need as many channels as you can get. In fact, you may even have to avoid certain channels thanks to your neighbor. Well, when interference is up, capacity is down. Wireless spectrum is a very finite resource. So each time you increase the modulation, you boost those spatial streams or glue more channels together, you're going to run into these environmental realities. Well, as you would expect, Wi-Fi 6 has great drag strip numbers in all three areas. But for the first time ever, there's a fourth: airtime efficiency. Think of airtime as a single lane 20 MHz wide. There can only be one transmission in one direction at a time. Well, each transmission opportunity is limited to one frame, no bigger than 2,300 bytes. Now, if you look at your own network, you'll see that the average frame is at most 350 bytes, which leaves a lot of wasted space. Wasted space equals wasted airtime. In other words, it's not efficient. Well, Wi-Fi 6 is addressing this with a big new acronym, OFDMA. Each transmission will now be optimized and combined using smaller resource units. And these RUs are assigned by the AP to match application requirements, which allows multiple clients to transmit in parallel, both uplink and downlink. So instead of sending one lightly loaded frame for every tiny payload, now there could be as many as 9 IoT or say real-time video streams, each getting a dedicated 2 MHz channel with data rates approaching 14 megabits. Now that's a huge improvement for each transmission, but what about the time wasted just waiting for the chance to transmit? Well, 802.11 devices follow a set of access rules. Listen before talking. If you hear anything, wait, then try again. High-density environments will have more access points carefully tuned to create smaller cells, but clients are selfishly shouting at full power, and it'll make the channel look busy, so others will wait, even if they could actually be transmitting. Wi-Fi 6 now offers BSS coloring, so that each of these smaller cells, or BSSs, can identify as being on the same team. And the AP will then offer an incentive for their team members or clients to reduce their power. They say, you don't have to talk so loud, turn your power down, I'll give you preferential channel access. Net result, the entire noise floor goes down. Each client gets the best quality connection possible. Well, these efficiency gains are also breathing new life into MU-MIMO, and regardless, Wi-Fi 6 makes it mandatory, both down and now upstream. And this allows acknowledgement frames to respond in a more parallel, efficient way than they ever could have before. The whole thing can operate more like a system. Now to recap, the efficiency of OFDMA fully optimizing every transmission, BSS coloring getting rid of unnecessary wait time, all with more capacity than ever before thanks to MU-MIMO. Now just remember, device support is key. We need critical Wi-Fi 6 mass before we will see any of these rewards. Oh, just in case there's any confusion, Wi-Fi 6 is complementary but not the same thing as 5G. It's two big wireless developments, each serving unique parts of the market. Wi-Fi 6 is the most important technology under your control. How devices actively transition between both Wi-Fi and the service providers is already getting a lot of focus. I wish we had time to cover the other improvements, right? Target wake time, better battery management, the return of 2.4 gigahertz. Wi-Fi 6 is all about the efficiency. Better efficiency means better, more predictable mileage.